Here in this video, we would like to talk about the parallel grouping of a cell. Cell is a kind of a device which generates some EMF and drives the current in the circuit. What do you mean by parallel grouping? Let me try to explain. This is a cell 1 having some EMF E and internal resistance R. If you connect another cell like this, positive to positive and negative to negative, this is called parallel grouping. You can connect as many cells as you want in parallel grouping. Let's imagine we have connected some n number of the cells in parallel grouping, each having an internal resistance R and EMF E. Let us say these are all connected to a external resistance R, capital R. What is the current generated in this circuit is the question that we would like to discuss. You know, when the cells are connected in parallel, EMF doesn't adds up because in parallel voltage remains the same. So what's the total EMF in the circuit is E itself. Even after connecting n number of the cells, EMF is E itself. Then total resistance of cells. Each cell is having a resistance R. This R and this R are connected in parallel. This R is connected in parallel is equal to the n cells each of R in parallel. You know, the formula for identical resistors in parallel is R by N. So the effective resistance becomes R by N. So that's the total internal resistance R by N that acts like a, we have already discussed this. Internal resistance act like a series resistance. Acts like a series resistance. So the total internal resistance NR is in series with external resistance capital R. That implies the total resistance of the circuit could be series resistance. Therefore, R plus R in series. Total resistance means you have to add all of them. Now I know the total resistance. I know the total EMF. Now I can calculate the total current in the circuit. That implies total current in the circuit I equal to total EMF by total resistance as per the Ohm's law. This is what the value of the current is. You can rearrange these terms as I NR plus R by N, or the value of the I can be written like NE by NR plus R. This is the total current in the circuit in the parallel grouping of the resistors. So when we can prefer this kind of a parallel grouping, let us try to understand that. What happens if internal resistance is much bigger than the external resistance, right? What happens if internal resistance is much bigger than the external resistance? Then I can ignore this NR. I will become NE by R, gives a maximum current. What happens if the case is reverse? If say internal resistance is much smaller than the external resistance, then I need to ignore this internal resistance and the current becomes NE by NR, E by R, that is equal to the current of one cell itself. Therefore, parallel grouping works well or useful to drive maximum current only when the internal resistance is much bigger than the external resistance. If internal resistance is equal to the external resistance, then of course there will be some current. If internal resistance is much smaller than the external resistance, the current driven is small. Therefore, preferable connection is, if you compare with the series grouping that we have done in the other video, it is the other way, right? So parallel grouping is preferable when internal resistance is much bigger than the external resistance. Series grouping is preferable other way. Preferable. You can refer the previous video. Series grouping of the cells is preferable when the external resistance is dominating internal resistance. Parallel grouping is preferable when the internal resistance is dominating the external resistance. You might have a question like, what if some cells are connected wrongly? Even some cells are connected wrong, even if some cells are connected wrong, that means in reverse connection, EMF resultant is E itself, because even one cell gives the same EMF of E. Therefore, wrongly connection of cells is not going to affect the current generated in the circuits in the case of parallel grouping. It affects only in the case of series grouping. This is how we have to study the parallel grouping of cells. Thank you for watching.